My bad, guys. Okay, brother or sister Blackham, we have been meeting for the last hour-ish or half hour, and I forgot to put it on start broadcast. So we've been working on the quiz. Here's our work so far. We're just finishing up number 4, but we've been here, so sorry. Okay, anyway.
Okay.
So.
Okay, so the logs and then put it in exponent form, and it's just solve for x. So it's gonna be super easy, and it's one that I think we've already done before.
Did you put them? If I understood correctly, did you just put them together as like division?
Mm-hmm.
Okay.
So log of x over x minus 1 equals 2. Then you put it in exponent form, so 10 squared equals x over x minus 1.
Mm-hmm.
And then 100 equals x over x minus 1. Multiply both sides by x minus 1.
Mm-hmm. So we should get 100x minus 100
equals x. And then you just subtract x. 99x. And then add 100. 99x equals 100. And divide by 99. X equals 100 over 99.
Yeah, this totally feels like one we did before.
Yeah.
Cool.
Ta-da! All right, we're all done with the group quiz.
Yay.
Yay.
2 minutes long. Just kidding, it was 35 minutes.
Yeah.
I know. Would you guys mind terribly? Unless, is there anything you guys want to go over on the quiz before we wrap that up?
Jaden, do you want us to walk you through the expansion one?
No, I'm good.
We got done all early. You sure?
Yeah.
Okay.
I'll have Albert go over it with me when we have our tutoring.
Okay.
But you don't have to pay me to go over it.
I don't pay him.
You don't pay him?
No.
What?
Yeah, you don't have to pay for tutoring.
Oh, is it through BYU Idaho?
Yeah.
Oh, sweet.
You know, Albert, our math TA.
Oh, Albert is tutoring you?
Yeah.
That's sweet. Oh, okay. Well then.
Would you guys mind terribly if we did? I struggle with these graphing ones. I can never seem to put it in right.
Okay.
On the extension problems, there's 2.
Expansion problem?
Uh-huh.
Okay.
Right, it's like if you guys like either like whoever knows how to do it, if you wouldn't mind like just kind of walking me through it, and then if the other one doesn't want to stay, I mean that's fine too. We finished the stuff, so if you want to go.
Okay, wait. Which one are we doing?
If we could do like just both of the graphing ones, that'd be awesome.
And at the beginning,
yeah.
Number 1 on the extension problems.
Mm-hmm.
Yeah, sweet. Let's do it.
Okay.
Okay. So.
So it looks like it'd be to the right 3, up 2, and then also be reflected.
Yeah. So it's going to be the graph of -1/2 to the x. So
how do we know what that looks like?
Okay, let's just identify all the transformations. So right 3, up 2, reflection across x.
Mm-hmm.
And then, since it's 1/2, is that going to mean that it's a, what do you call that? A vertical compression?
A stretch or a shrink? Yeah, is that?
Yeah.
So in the answer key, it says there's no stretch or shrink, and so that was kind of confusing me.
Okay. So I think the reason why is because the parent function is y equals 1/2 to the x. And
Okay.
so if there was something in front of the 1/2, like with the negative, then it would be a vertical stretch or compression. That's why I wasn't sure.
Oh, I
But
see.
Yeah.
I guess if there isn't with the graph then.
Okay.
Okie doke. Then to graph this, we're gonna want to put a vertex.
So how do we know what the parent graph looks like, though? I mean, what does 1/2 to the x look like?
I would plug it in a graphing calculator.
Or Desmos.
Are we allowed to use Desmos on the test?
I don't know.
Yes, Desmos is just a graphing calculator, so
Cool.
we would be allowed to use it.
Oh,
So
sweet.
if you don't have an actual graphing calculator, then yeah, you can.
Great, because I can never figure out how to use a graphing calculator. Like, I learned to once, but it's been like 4 years.
Yeah, that makes it rough.
And I'm like, I could barely do it then. I can't even do it now. Like, I've done it on accident a few times. Like, I've been typing in my equation to solve it, and then it'll be like, oh, here I am. I'm the graph. And I'm like, I don't need the graph on this question. Go away.
I'm the graph. Okay, to the x minus 3.
Okay. Sweet.
Plus 2. So then, let's see. Minus 3 plus 2. So, whenever it's a graph where it's something to the x, then usually it just has like a shape like this.
Yeah, okay.
So then you just move the vertex point and then just whoosh. And you can plug in a couple of points just to be more accurate on either side of the vertex. And then just graph it like that. It's super simple.
So the domain should be negative infinity to infinity.
The range?
The domain?
Domain, yeah. Domain and range are both going to be negative infinity to infinity.
Okay. But then on the answer key, she has range as negative infinity to 12.
To 12?
Yeah. And then she has right underneath that, she has a 0, comma, negative 6 as well.
Well, that's because I think she's saying there's a horizontal asymptote. Yeah, that's what it is. That's the right word.
Oh, yeah.
And so that's why the range has that limit.
Okay.
Okay, so infinity to 12.
She didn't ask for that, though, in the question, but maybe it's good to know how to do it anyway. 12. Wouldn't it be to like...
6 is not part of the range. That is the y-intercept.
Oh, it's the y-intercept. Okay. So what's the 12, though?
Okay, so I guess there is an asymptote at 12. And I guess we would find that by looking for horizontal and vertical asymptotes. There's not going to be a vertical one based on looking at that, but I guess there would be one at 12. Let me see here. But I thought that it was at 2.
Right?
So I don't know why it says 12. Plus, she has her asymptote drawn at 2.
So can we just maybe assume that that was a mess up?
Yeah, I guess so. It should be negative infinity to 2.
Okay, cool. That makes sense.
Yeah.
Okay.
And for the second one, it's a logarithm. Woo! Which means, okay, so for exponential, then the asymptote's going to be horizontal, but for logarithms, the asymptote, unless it's transformed, will be, oh, wait. 1 second. Brain. I think that's true. It's usually a vertical asymptote.
Okay.
And it should be at x equals -4. So what's inside of the log equal to 0?
And there's no reflection.
Yeah, correct.
Then what's that 2? Is that telling us it's going to be a stretch?
Yeah.
Okay.
Okay,
This
so
is
the
one-
new vertex, we're going to put it at -4, -3. Then vertical asymptote at x equals -4. And then just plug in a couple other points around the vertex to know where to put the other 2. Or the other points.
Okay.
That's the easiest
Sweet.
way to graph things like this. Look for vertex, asymptote, and then plug in a couple more points.
An option to put. There it is. Okay, cool. All right. Thank you very much.
Everything makes sense?
I think so.
We all
All right.
good?
Sweet.
I'm good.
All right.
Okay.
Good job, guys.
Sweet. And then the first half of our quiz, we had great discussions. So just
Yeah, we
throwing that
did.
out there.
Yeah.
We crushed it. I'll make a note of that too when I submit the Word
Okay.
document.
I think
Thanks,
that was
Connor.
probably
Best of luck
the
with
quickest
everything.
we've done the quiz.
What?
Yeah.
I think that's
so too.
actually the quickest we've done the quiz.
Yeah, you're right. We have proof. All right.
Cool.
Thanks for writing again, Connor.
No problem. See you guys next time. Have a good weekend and good luck on the test.
All right. See you guys.
Bye.
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 Stop